Imagine a world where you hand over the keys to a very intelligent assistant. You trust it to handle customer support, write code, or summarize complex documents. You assume that once you deploy this system, it will remain consistent. But the reality is far more complex. Large language models are not static statues. They are dynamic systems that evolve as they interact with the world. This evolution is not always improvement. Sometimes, the behavior drifts. Here is the thing. Most teams monitor their models for uptime and latency. They check if the server is running and if the response time is under a second. But they miss the subtle shifts in quality. A model might still answer quickly, but the tone could become more aggressive. The facts might start to drift. This is known as drift. It is a silent failure mode that standard monitoring does not catch. Consider a musician playing a concerto. If they play the wrong note, you hear it immediately. But if they gradually change the tempo or the dynamics over a month, you might not notice until the performance feels entirely different. Large language models behave similarly. They might start using slang they were not trained to use. They might lose their professional tone. Or worse, they might begin to hallucinate facts that sound plausible but are completely wrong. This drift happens due to data shifts in the environment or subtle updates to the model weights. To understand why this matters, we must look at the broader context of artificial intelligence research. Recent studies from the mid-2020s highlight a rapidly evolving field. There is a strong consensus that artificial intelligence is moving beyond narrow tasks toward generalized capabilities. However, this speed brings risks. Researchers have raised concerns about cognitive offloading. This is where humans rely so heavily on artificial intelligence that their own thought processes change. If the model itself is drifting, the quality of human decision-making degrades further. So how do we catch this drift before it impacts users? The answer lies in artificial intelligence observability. This goes beyond simple metrics. It involves analyzing the actual outputs of the model over time. One practical technique involves embedding similarity. You take the output of the model and convert it into a mathematical vector. By comparing this vector to previous outputs, you can detect semantic shifts. If the vector moves too far from the baseline, it signals a change in style or content. Now consider the tools available. Open-source frameworks exist that allow you to log these interactions without proprietary lock-in. These tools track the conversation history and flag anomalies. They can identify when a model starts answering with a different sentiment or when it begins to omit critical safety guardrails. This is crucial for production environments where trust is the currency. You need to know when the model stops behaving like itself. Once you detect drift, you need a response. Automation is key here. You can set up triggers that alert your engineering team when drift exceeds a certain threshold. In some cases, the system can automatically roll back to a previous version of the model. This ensures that users are not exposed to the degraded behavior. In other cases, you might trigger a retraining pipeline. The system gathers new data from the drift period and fine-tunes the model to correct the behavior. This creates a feedback loop where the model learns to stabilize itself. This technical capability connects deeply to the ethical questions surrounding artificial intelligence. We are seeing a surge in interdisciplinary work. Computer science is merging with ethics and social science. The goal is not just to build smarter models, but to build trustworthy ones. The pursuit of artificial general intelligence continues, but it must be grounded in safety. If we cannot observe the behavior of our systems, we cannot align them with human interests. Think about the implications for human cognition. If an artificial intelligence tool begins to hallucinate facts, and a human relies on it for research, their understanding of the world becomes distorted. This is the risk of algorithmic manipulation. It is not always malicious. It can be a side effect of drift. By implementing rigorous observability, we protect the integrity of human thought. We ensure that the tool serves the user rather than subtly altering their perception. In a production setting, this means changing your definition of reliability. Reliability is not just availability. It is consistency of quality. You must define what good looks like for your specific use case. Is it a specific tone? Is it a specific level of accuracy? Once defined, you build the observability layer around it. You monitor the distribution of outputs. You watch for outliers. You track the semantic distance between today's responses and yesterday's. This approach requires a shift in mindset. It moves the conversation from deployment to continuous validation. You are no longer just shipping code. You are managing a living system. This is the reality of modern artificial intelligence. The models are powerful, but they are fragile in ways we are only beginning to understand. As we look toward the future, The demand for these observability practices will only grow. The volume of submissions in the field is outpacing our ability to assess impact. We need systems that can keep up. We need tools that can detect the subtle shifts before they become catastrophic failures. This is not just about technical performance. It is about maintaining the trust between humans and machines. Ultimately, the goal is to create a safety net for the intelligence we are building. By focusing on observability, we gain the visibility needed to manage complexity. We ensure that as our models evolve, they evolve in the right direction. We safeguard the quality of information that flows through our digital infrastructure. And in doing so, we protect the cognitive space that humans need to think, learn, and make decisions. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.